At the edge of a quiet town in Ohio, surrounded by security fences and guarded gates, sits one of the most important factories in the United States. From the outside, it looks like an ordinary industrial building. But inside, workers are building one of the most powerful tanks ever created. A machine designed for the battlefield. A machine that has shaped modern warfare. Welcome to Process Explained, where we uncover the real processes behind the world's most powerful factories and technologies. Today, we're stepping inside one of America's most important military production facilities to see how these massive war machines are actually built. Chapter 1. The Lima Tank Plant. In the city of Lima, Ohio, there is a massive industrial facility known as the Joint Systems Manufacturing Center. The plant was originally built during World War II to produce tanks for the U.S. Army. Over the decades, the factory has produced several generations of armored vehicles. Today, the plant is operated by General Dynamics Land Systems. Its main job is producing and upgrading one of the most advanced tanks in the world, the M1A2 Abrams. This tank weighs more than 70 tons, carries a powerful 120mm cannon, and is designed to survive some of the harshest combat environments. Each tank contains thousands of components, including advanced armor, powerful engines, sophisticated electronics, and weapon systems. The first step in building an Abrams tank is constructing the armored hull. Unlike ordinary vehicles, tanks require armor strong enough to withstand explosions, bullets, and anti-tank weapons. The Abrams uses a combination of materials for protection. The base structure is made from high-strength steel plates that are cut using computer-controlled machines and welded together to form a hull. Inside the armor layers are special composite materials, including ceramics and classified protective layers that help absorb the impact of incoming projectiles. Some sections of the tank also use depleted uranium armor, a dense metal that significantly increases protection against enemy fire. Because of the complexity of this armor, much of the work must be done manually by highly trained welders and technicians. Once the armored hull is completed, the next step is installing the engine. Unlike most tanks, the Abrams is powered by gas turbine engines similar to those used in aircraft. The engine used is the Honeywell AGT1500 turbine engine, producing around 1,500 horsepower. This allows the 70-ton vehicle to reach speeds of over 40 miles per hour. Gas turbine engines provide strong acceleration and can run on multiple fuel types, including diesel and jet fuel. After installation, technicians connect the transmission, cooling systems, and fuel lines. After the engine is installed, the next stage is equipping the tank with its weapon systems. The primary weapon is a 120mm smoothbore cannon capable of firing armor-piercing rounds and high-explosive shells. The cannon is mounted on the rotating turret, which houses the gun system, targeting equipment, and crew stations. In addition to the main cannon, the tank also carries machine guns used for defense against infantry and light vehicles. The targeting system includes thermal imaging and laser range-finding technology, allowing the crew to detect targets even at night or in poor visibility. Modern military vehicles rely heavily on electronics. Inside the Abrams tank are advanced computer systems that assist the crew with navigation, targeting, and battlefield communication. One of the most important components is the fire control system, which calculates the exact angle and power needed for the cannon to hit a target. IT takes into account distance, wind speed, movement of the tank, and movement of the target. The result is extremely accurate firepower, even while the tank is moving across rough terrain. After all major components are installed, the tank enters the final assembly phase. Technicians inspect every system, including electrical connections, hydraulic systems, weapon controls, and engine performance. Once assembly is complete, the tank is painted with specialized military coatings designed to reduce corrosion and improve camouflage before being delivered to the U.S. Army. Every Abrams tank undergoes extensive testing. These tests include engine performance checks, weapons calibration, and mobility trials. The tanks are driven across rough terrain to test suspension systems and durability. Only after passing these inspections is the tank approved for service. The Abrams tank has been used in several military operations around the world. It entered service in the early 1980s and played a major role during the Gulf War in 1991. The tank was also used extensively during the Iraq War beginning in 2003. Today, it continues to serve as the primary battle tank of the U.S. Army. Allied countries such as Poland, Australia, and Egypt also operate versions of the Abrams tank. Factories like the one in Lima, Ohio, quietly build some of the most powerful military machines on Earth. From massive armor plates to powerful turbine engines, every component is engineered with precision. And here on Process Explained, we explore the incredible processes behind the world's most powerful machines and technologies. If you enjoy discovering how complex systems of factories actually work, make sure to subscribe to Process Explained for more deep dives like this.